With two well-timed claps, AC appliances can be turned on and turned off. We can also turn on lamps and turn it off. As long as it is an AC appliances that consists of 240 volts of AC, we can turn on anything: lamps, fans, chargers, laptops, and so on. This is how the circuit for the AC appliance hand clapping device looks like. The star of this project is, of course, the sound sensor card, which features the electric microphone here. The VCC on the sound sensor is connected to the VCC on the Arduino. The ground connected to ground Arduino. Then, the output of the sound sensor is then connected to the analog pin A0 on the Arduino. Moving on, this is what the actual circuit of the sound sensor looks like. It features an electric microphone here, a few resistors, capacitors, and an NPN transistor here, with also a variable resistor of 10 kilo ohms. The use of these extra components is to beef up the audio signal to higher voltages when signal is received. Next, the LM393 here is used to amplify the audio signal. Plus, the variable resistor of 10 kilo ohm here on the sound card can be adjusted to a certain sensitivity and range of sound input. Furthermore, this is the output part of the circuit, which has a 5 volt DC relay in combination with an NPN transistor and a flyback diode. The normally open pin on the relay here is connected to the 240 volts of AC as the voltage source to power up AC appliances. Whenever an input source is given to the sound sensor, it delivers to the pin 13 on the Arduino, which is connected to the base of the transistor here. Then, the signal or voltage source passes through the coil, and to prevent the signal from flowing backwards and moving back to the transistor, a flyback diode is used here. Furthermore, after the coil has been triggered, the normally open pin here is set to normally closed, then allowing 240 volts of AC to flow through the common pin and towards the socket, thus turning on AC appliances. The coding for the Arduino looks like this. Because the sound sensor is connected to the analog pin A0, the sound sensor is defined as the integer sound 0 equals to A0. Meanwhile, because the pin on the Arduino is connected to the relay in combination with an NPN transistor and a flyback diode, it is also defined as integer relay equals to 13. Next, the integer clap equals to 0, the long detection range equals to 0, means that at the initial state, it starts with no high voltage or no sounds, plus the Boolean status light is set to false, or in binary is 0 because no input sound is given in the initial condition. Furthermore, to make sure that the Arduino recognizes which is input and which is output, the print mode command is used, whereas the sound sensor is set as the input and the relay as the output. Moving on, the digital read command here is used to read the status of any digital pin on the Arduino. Plus, the digital pin needs to be in a bracket like this, and because the sound sensor has already been defined above as A0, so just the sound sensor is in bracket. Next, the status sensor equals to 0 is because there is no sound inputted to the sound sensor. The detection range here detects how far the sound of two well-timed claps can be captured. The millis function right here returns the number of milliseconds that the Arduino board has been powered up. As soon as the sketch has been uploaded to the Arduino, the clock starts counting, and once it reaches its limit, which is up to this value in seconds, and then it resets and starts back to 0. Usually, millis is used as time repetitive events. Because the detection range is set to 0 and the detection range is set to count the millis function, which is rapidly increasing whenever we uploaded the sketch to the Arduino. The first condition is that when no clapping occurs, so the value of detection ranges are the same as the millis. But when the clap is larger than 0, right here, which is the first clap, and the millis have subtracted to the value of detection range is larger or equal to 50, the clap plus from 0 to 1, making it as the first clap. Then, if millis subtracted to the detection range is equal or larger than 400, it is recognized as the second clap. Moving on, the status light with an exclamation mark here means that the status light defined above is actually the opposite of false, which is true. For an example, if I write exclamation Y equals to X, it's actually Y not equal to X. But if I write Y equals to X, it is actually Y equals to X. So the exclamation mark is actually the opposite of this value. Then the digital write writes the relay pin of 13 as high, thus turning on AC appliances. Else if the status light does not have any exclamation mark inside this bracket, the status light is actually false as stated above here on the Boolean status lights, thus making the relay input as low and not turning on AC appliances. After that, the clap is now set to 0, starting the process over again. Then, after the coding has been written, it is then compiled, and then moving to tools, selecting the right board, which is the Arduino Uno, the serial port COM3, it is then uploaded. And there you go, done uploading. The actual circuit looks like this. It is very hideous and unorganized. Plus, if a person accidentally touches the circuit, it would be very dangerous because 240 volts of AC can definitely kill us. Therefore, the circuit needs to be placed and modified into a more compact space, such as a plastic container. The actual plastic container looks like this, whereas all the circuitries are placed inside for safety purposes. Moving on, in order to minimize the circuit space, a 5V DC switching power supply is used to power up the circuits and Arduino, rather than relying on a power bank. When measuring the output voltage of the power supply unit using a multimeter, it shows that the output voltage delivers around 5 volts of DC, which is sufficient for the circuits and Arduino to function properly. Next, the modification of the circuit starts with identifying where to place the AC socket input and the switch socket output. The AC input and output socket are measured and the rough outline are marked on the plastic container for a perfect cut. After that, the marked outlines are drilled using a battery power drill and cut using a rotary tool so that the AC input and output socket fits into the plastic container. After that, screws and bolt nuts are used so that the AC input and output sockets stays in place. After that, holes of the electric microphone are marked on the plastic container so that only the electric microphone passes through the container lid and not the whole sound sensor. Then, the drilling process is done to fit in the electric microphone through the hole. Moving on, the sound sensor are then secured on the container lid using some hot glue, because hot glue does not create any short circuits when in contact with the conducting path. And this is what the container lid looks like, with the electric microphone through the lid and not the whole sensor card. Furthermore, the connections of the circuit are done by soldering the socket wires to the AC input sockets and connecting the other connections on the breadboard. The soldering part are done carefully so that the earth, live, and neutral connections are not in contact. This is what the device looks like when all the connections are done properly. Plus, wire connectors along with shrinkers are used to hold two wire joints together to avoid short circuit if the wires are in contact with each other. This is what the finished product looks like. All the circuitries are stored inside for safety purposes, and needless to say, it looks clean and simple compared to the first circuit created. AC Appliance hand clapping device has many beneficials, and it surely has high demands in the market nowadays because of its functionality. The first benefit is to avoid physically in contact with the mechanical switch, so that we can reduce the chance of getting electrocuted by 100%, Because with this device, the person does not require to touch any switch, so that the chance of getting electrocuted can be eliminated. Next, it is a great device for elderly, children and those with immobilities because switches nowadays are hard to reach. So, with this device, we can surely help elderly, children and those with immobilities daily tasks better. The third benefit is it has low cost because this device requires only simple and cheap components. Surely, it is beneficial to build one as it is surely not that costly. Moving on, because this product has high demands in the market, the prices will also increase because the supply and demand is actually directly proportional. Other than that, people nowadays rely on smart home system to remote control home function because of its functionality. Therefore, this is what causes the price to increase because of the high demand. Lastly, this project can be improved to much greater ideas as it uses a microcontroller. Now, this is how the final product looks like. We can now turn on and off AC appliances with 2 well-timed claps. And thank you for watching. Bye.